Hey guys, what's up? My name is Hyro, and I want to talk to you today about microrhythm notation. So I've done a couple videos before about microrhythms, but I've never really gotten to talk about them in detail, and that's what I want to do today. I want to try and do somewhat of a lecture to try and go through what microrhythms are and how they can be notated. So a little bit of a disclaimer, this lecture is going to be a bit heavy. So if you feel like you aren't understanding something, you might want to watch it over a couple times. But I'll try and be as thorough as I can be with it, right? So microrhythms. So what are microrhythms? We'll consider them to be the slight timing deviations in rhythms. For example, if I had a 4-note rhythm, like 16th notes, then we can say that they sound like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So if, for example, we were to take the second partial of the 16th note and move it slightly earlier, then we can get something that sounds like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, with a slight hiccup at the beginning of the rhythm. Or if we were to take the fourth partial and then move it slightly later, then it would sound like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, with a slight hiccup towards the end of the rhythm. So these are what we would call microrhythms. You have these slight microrhythmic imperfections in those rhythms, those slight deviations, and it doesn't really seem like that complex of an idea. And it seems very easy to play when you're listening to it. But the complexity behind these ideas comes when it comes to notating these rhythms, especially using music software. So even though I'm talking about all this stuff in terms of music, this is actually going to be a math-heavy lecture. And I'm going to try and do the best I can to explain how everything is tied to music every step of the way. So the end goal of this lecture is to explain how these complex microrhythms work and how to notate them in the simplest way. One quick thing before I dive into this, I just want to address something. So a lot of people ask, why are microrhythms important? Why is it necessary if you can't even detect them most times? And it's true, you can't. They're inaudible for very slight deviations. But just like with timing, or just like with tuning, I always think, well, why do we fine tune instruments instead of just tuning them roughly where we want them to sound? And it's because those slight deviations in things like tuning or timing can actually add a lot to how we experience the music. So a slight deviation in timing can add a lot more uneven weight distributions to the beat. So knowing how to notate these microrhythms allows us to get the perfect playback of these rhythms every time we want. All right, let's dive into this. So in order to notate, or in order to visualize these rhythms, we're going to draw a number line. We're going to say we have a number line to represent the space of one quarter note. To represent the beginning of the beat, we're going to draw a 0. And to represent the end of the beat, we're going to draw a 1. So this is the end of the first beat or the beginning of the second beat. Same thing. Now, since this is a space of one quarter note, technically we can say that we could have like 1 and 2, or 1E and a 2, or 1 and a 2. Using different dots, we can say that if we wanted 1 and 2 eighth notes, then we can notate 1 and 2. A dot here, and dot here. Or if we wanted 16th notes, we can notate 1E and a 2. 4 dots, and the next downbeat. But for the purposes of having an example to work with, we're going to make up a 4-note rhythm with some microrhythms in it. So it's going to sound like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And it's going to be notated like this. So we're going to have our first note on the downbeat, so we're going to draw a dot on the downbeat. Now for the second note, we're going to say he is exactly where the second partial of a quintuplet would be. So for a quintuplet, we want to take the space between 0 and 1, which is the space of a quarter note, divide it into 5 equal pieces, 1, 2, 3, 4, 5, next beat, and we want to take the second of those pieces. 1, 2. So he would approximately be here. Now for our third beat, we're going to say he's exactly between 0 and 1. So on the upbeat. So exactly halfway would be right here. For our fourth beat, we're going to write him where the last partial of a triplet would be. So for a triplet, we want to take the space between 0 and 1, divide it into 3 parts, and we want the last partial. So right here. And for reference, we're going to suppose that after this 4-note rhythm, we're going to have another downbeat. So above the 1, we're going to draw another dot. Now we have our rhythm notated. We have it drawn out to where we want them to be. But where are these exact rhythms? Where is this note? Where is this note? So now we got to draw the timestamps. So for this first note, we're told he's at 0 at the beginning of the beat. So we're going to put a timestamp of 0. For the second note, we said he's the second partial of a quintuplet. So we want to take the space, cut it into 5, and then we moved over 1 piece. So we moved 1/5. For the third note, we took the midpoint between 0 and 1. So we have half, 1/2. For the third note, we wanted the last partial of a triplet. So we took the space between 0 and 1, cut it into 3 parts, and then we moved over 2/3. So we write 2/3. For reference, we're going to say our next beat we're given is 1. So there's our timestamps. There's when we have these notes happen. This is at the beginning of the beat. This is at the beginning of the next beat, right? And all the in-betweens. But in order to notate this, we need to find the length of each note. So we can use these timestamps in order to help us find those lengths. For example, the length of the first note is this space right here, the length of this space. But in order to find it, we can take the timestamp of the second note, which is 1/5, and subtract the timestamp of the first note, which is 0, and we can find the space of the first note. So we have 1/5 minus 0, and that gives us 1/5. That means that the first note lasts for 1/5 of the beat. Now for the second note, we need this space. How long is this space? So we can get that by taking 1/2 and subtracting 1/5. 1/2 minus 1/5. In order to do this, we can't just subtract because they have different denominators, so we have to get a common denominator. So 1/2 is the same thing as 5/10. We're going to draw everything or rewrite everything with 10 on the bottom because that's the common denominator between 2 and 5. So 5/10 and 1/5 is the same thing as 2/10. So now we rewrote each of these fractions with 10 on the bottom because of the common denominator. After we subtract, we get 3/10. So now we know that this beat lasts for 3/10 of the beat. 3/10. For the third note, we need this space. So we're going to take 2/3 and subtract 1/2. 2/3 minus 1/2. We need a common denominator of 6. So we rewrite these with 6 on the bottom. So 4/6 minus 3/6 is the same thing as 1/6. So we get third note is equal to 1/6 of the beat. Now for the last note, we need to take 1 and subtract 2/3. So 1 minus 2/3 gives us 1/3. That means that the last note lasts for 1/3 of the beat. So as it stands right now, we can technically notate this already. We can say that this first note can be notated as 1 partial of a quintuplet because it's worth 1/5 of the beat. Or that this partial, or that this note right here could be notated as 3 partials of a dectuplet tied together because it's worth 3/10 of the beat, and so forth. So we can notate this like this, but they'd technically be under different households. The first note would be notated as quintuplets, the second note would be notated as dectuplets, sextuplets, and triplets. But in order to notate them all under the same household, we need to find a common denomination for all these rhythms, or a common denominator. So we can look at the denominators we have for 1, 1/5, 3/10, 1/6, and 1/3, which is 5, 10, 6, and 3. We can take these denominators and we can find the least common multiple. So this is the smallest number that all of these numbers go into evenly, which is 30. So we can now write each of these fractions with the 30 on the bottom. 1/5 is the same thing as 6/30. So we'll write 6/30. 3/10 is the same thing as 9/30. 1/6 is the same thing as 5/30. And 1/3 is the same thing as 10/30. So now technically, this is saying that we can take the space of a quarter note and subdivide it into 30 equal spaces. And this first note is going to be worth 6 of those partials tied together. And this second note is worth 9 of those partials tied together. And this third note is worth 5 partials tied together, and so forth. But now we got to think, what do we actually use to notate a 30 tuplet? Something that divides one quarter note into 30 equal parts. But we don't know, because this isn't something that we're familiar with. But let's think, what are we familiar with? In the space of one quarter note, we can write one quarter note, right? Or we can write 2 eighth notes. Or we can write 4 16th notes. Or 8 32nd notes. Or 16 64th notes, 32 128th notes, or 64 256 notes, and so forth. So these are all just powers of 2. This is 2 to the power of 0, which is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And this is 2 to the power of 3, 2 to the power of 4, and so forth. This is what the Western notation system is based on. Denominations that fit these subdivisions. So quarter notes have 1 subdivision, eighth notes have 2 subdivisions in this case, and so forth. But what we're looking for is 30 subdivisions. So what comes closest to 30? We can't notate this using just a regular note, because we don't have 30 subdivisions in here. What we have to do is introduce a tuplet and say that in the same space as some of these regular subdivisions, we're gonna fit 30 beats. So let's think, what's closest to 30 beats? So which one of these is closest to 30? It's this guy, the 32. What note value is the 32? What do we use in order to notate this guy? So we said this is quarter notes. We can fit 1 quarter note in this space, 2 eighth notes, 4 16th notes, 32nd notes, 64th notes, 128th notes. So this guy is a 128th note. So that's what we're going to start with. We'll write a 128th note. So this is a quarter note. That means that this is an eighth, 16th, 32nd, 64th note, 128th note, 5 tails. So technically, we can write 32 of these guys side by side, and they would take up the space of 1 quarter note. Now what we're saying is that we want to fit 30 of these guys in the same space as 32 of these guys. So we can now introduce a tuplet that is a 30 against 32. So we're going to draw a bracket to fit all of our 4 notes under the same household, right? 30 subdivisions. And we're going to say that we want 30 in the same space as we would normally have 32 of these guys. So there's our household now. Now we can start actually notating this rhythm. So the first note, we have 6 30 tuplets that we need to write. Technically, this is considered a 30 tuplet right now, a 128th note. This is the same thing as a 30 tuplet. So as it stands, we can write 6 of these guys side by side, tie them all together, and we would satisfy the requirement for our first space. And for the second note, we can write 9 of these guys side by side, tie them all together, and we would satisfy the requirement for the second space. And this would work, but this would work for sound purposes, but this wouldn't be the most convenient way of notating the rhythm, or the most compact. So alternatively, we can combine different note values in order to fulfill that same space. We need the space of 6 128th notes as it stands. So we know that this 128th note takes up the space of 1 128th note, right? Which means that this 64th note takes up the space of 2 128th notes, or that this 32nd note takes up the space of 4 128th notes. So in theory, if we wanted to fill up the space of 6 128th notes, this is worth 4 of those 128th notes, and this is worth 2 of those 128th notes. So a 32nd note and a 64th note tied together can satisfy that space, right? But what we've learned here is that if the number of subdivisions that we're looking for, so in this case 6, if this number of subdivisions is not a power of 2, then we can't notate this space just using one note. For example, right here we need 6 subdivisions, so not a power of 2. Here we need 9 subdivisions, not a power of 2. These aren't powers of 2 either. So we can't notate any of these spaces just using one single note. So now the workaround for this, for the sake of being compact, we're going to try and notate this actually using one note. For this, we're going to go back to what we're starting with our 128th note. And since we know that if our number of subdivisions is a power of 2, then we can reduce the notation down to fill up the space that we need with just one note. For example, like if this 6/30ths was 4/30ths, right, we need to write 4 128th notes to satisfy that space. Or in that case, we could just write 1 32nd note and we would be good. Once again, that's because 4 is a power of 2. So when it's a power of 2, we can reduce the notation. It's good. But 6 isn't a power of 2. So we're going to have to introduce a tuplet in this case for every space right here that is not a power of 2. So 6, 9, 5, and 10 aren't powers of 2. So for every space, we're going to have to introduce a tuplet that is a power of 2. So for formality purposes, we're going to choose the subdivision that is closest to 6. So we want to fit 6 of these, so we're going to choose what's closest to 6. In this case, we'll just choose 4. Now what we're going to say is that we want to fit in the same space as 6 of these guys, we want to squeeze in 4. So our tuplet is just going to be for this first note. We're going to say that we want 4 of these guys for the same space as 6 of these guys. So 4 against 6 tuplet. Now technically, we can write 4 of these guys side by side, tie them together, and we would be good. There's our space. But once again, we said if our subdivision is a power of 2, we can reduce the notation so that we can write this as only one note. So once again, we said 4 of these tied together can fill up the space. So that means that 2 of these tied together can also fill up the same space. Or just 1 of these guys tied together. So 1 32nd note can fill up that space. There you go. We just reduced the same space that we were writing with 6 128th notes, now just using one note. So we introduced a tuplet, then we reduced the notation. So let's try this second note. We need 9 30 tuplets, or 9 128th notes. We're going to start with our 128th note. So we have our note. This is quarter, 8th, 16th, 32nd, 64th, 128th note. And we're saying that in the space of 9 of these guys, we need to fit in some power of 2, so that's closest to 9. So our closest power of 2 is 8. So we can say we want 8 of these guys in the same space as 9 of these guys. So we write an 8 against 9 tuplet. Now technically we got to reduce, so we can fit 8 of these guys in the same space that we can fit 4 of these guys, or 2 of these guys, or 1 of these guys. A 16th now. And there's our space. That's for the second space. There's our note. So for the third one, we have 5 30ths. 5 128th notes. So we're going to start with our 128th note. So quarter, 8th, 16th, 32nd, 64th, 128th. And we want to take up the space of 5 of these guys. So we want our closest power of 2. So we can introduce a tuplet. Closest to 2 or closest to 5 is 4. So we're going to say we want 4 notes in the same space as 5 notes. So I'm going to write it here. 4 in the same space as 5. That's for this guy. So now 4 of these fit in the same space as 2 of these, and the same space as 1 of these. So we reduced our rhythm. Next we have 10 30ths. So we have our 128th note, and we got to find our closest power of 2 to 10. So that's 8. So now we can say that we want 8 notes in the same space as 10 notes. So we can write 8 for every 10. Now we reduce. 8 of these fit in the same spaces. 4 of these, which fit in the same spaces. 2 of these, and the same spaces. 1 of these. And yeah, there's our 4-note rhythm. So using condensed notation, we were able to get something that seemed a little complex to notate, but we were introducing tuplets and we condensed it down to just 1 note for every space. All right, so let's do a quick recap of everything to just make sure we're all on board. So we took a rhythm that we made up, 1 2 3 4, 1 2 3 4, 1 2 3 4, and then we notated that rhythm, putting the dots exactly where we wanted each note. Then we found the timestamp of each note, the timing, and we subtracted them in order to find the lengths. And once we were able to do that, we said, well, we can't just notate that guy as 1 partial of a quintuplet, 3 partials of a dectuplet, and so forth. So what's the common household in order to notate them all? We said 30. We can write them all as a 30 tuplet or some form. So that's a 6 30ths, 9 30ths, 5 30ths, and 10 30ths. We found out that we can write 30 tuplets and say this guy's worth 6 30 tuplets, 9 30 tuplets, and so forth. Now, what did we actually use to notate a 30 tuplet? We found the closest power of 2 to 30, and we used that denomination. So we found 32, and we said, well, what's the note value for 32? That's a quarter, 8th, 16th, all the way until we got to 128th notes. Then we started with our 128th note, and we said we want 30 of these guys in the same space that we would normally have 32 of these guys. So we introduced a 30 against 32 tuplet. And instead of just notating every note just however we wanted, we used the most condensed notation so that we could notate each space using only 1 note. So we said that if our subdivision is not a power of 2, then we introduce a tuplet that is a power of 2, and then reduce the notation so that we can just fill up the same space with 1 note only. There you go. So we're gonna go, for understanding purposes, we're gonna go over another example, and we're gonna say that this is gonna be a 5-note rhythm. So I'm gonna go through this example a little bit quicker, but I'm still gonna make sure that everything is being explained. So for this 5-note rhythm, we're gonna make sure, or we're gonna have it sound like this. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, and so forth. So we're gonna notate this rhythm like this. We're gonna draw our line. We have the beginning as 0. We have the end as 1. Now we start writing in our notes. The first note is on the downbeat, so we're gonna put a dot on the 0. The second note is where the second partial of a sextuplet would be. So for a sextuplet, we take the space, cut it into 6, and then we take the second guy. All right here, approximately. For the third note, we're gonna say he is where the third partial of a quintuplet would be. So for a quintuplet, take the space, cut it into 5, and then move over to here. Now for the fourth note, we're gonna say that he is where the last partial of a triplet would be. So for a triplet, we're gonna take the space, cut it into 3 parts, and he's here. And for the last note, the fifth note, we're gonna put him where the last partial of a 16th note would be. So we're gonna say, take the space, cut it into 4, and he's approximately here. And for reference, we're gonna put our next beat right here. Now the timestamps, when do these notes happen? So for the first note, we're given that he's 0, we're gonna rewrite it 0. Second note, we said he's the second partial of a sextuplet. So we took the space, cut it into 6, and we moved over 1 piece. So 1/6. The second note, or the third note I meant, we said he's the third partial of a quintuplet. So we take the space, cut it into 5, and we move over 2/5. So 2/5, that's our timestamp. For this note, last partial of a triplet. So take the space, move over 2 parts, so 2/3. This one, he is the last partial of a 16th note, so take the space, cut it into 4 parts, and he is the last one, 3/4. In our reference note, we said he is 1. So now that we have the timestamps, we're gonna find the length of each note. We're gonna say 1/6 minus 0 is gonna give us the length of the first note. So 1/6 minus 0 gives us 1/6. So this first note lasts for 1/6 of the beat. Second note, we have 2/5 minus 1/6. So 2/5 minus 1/6. In order to do this, we gotta have a common denominator. So we rewrite each of these fractions with 30 on the bottom. 30 is a common denominator. So 2/5 is the same thing as 12/30. And 1/6 is the same thing as 5/30. So 12/30 minus 5/30, we get 7/30. So the second note lasts for 7/30 of the beat. 7/30. For the third note, we need this length, 2/3 minus 2/5. 2/3 minus 2/5 means we need a common denominator between 3 and 5, so we get 15. Rewrite each of these fractions with 15 on the bottom, so 10 over 15 minus 6 over 15, which is 4 over 15. So the third note I meant lasts for 4/15 of the beat. Fourth note, we have 3/4 minus 2/3, so 3/4 minus 2/3. Rewrite with 12 on the bottom, so 9/12 minus 8/12, and we get 1/12. So this space is worth 1/12. And last one, we have 1 minus 3/4, which is 1/4. So 1/4. Now technically we said by this point, we can notate the first note as 1 partial of a sextuplet, or the second note as 7 partials tied together of a 30-tuplet, and so forth. But in order to notate them all under the same household, we had to find a common denomination or a common denominator. So common denominator between 6, 30, 15, 12, and 4. What's their least common multiple? What's the smallest number that they all go into evenly? So that's 60. So we can rewrite each of these with 60 on the bottom. 1/6 is 10 60ths. 7/30 is 14 60ths. 4/15 is the same thing as 16 60ths. 1/12 is 5 60ths. And 1/4 is 15 60ths. Now technically this is saying that we could take the space of one quarter note, cut it into 60 equal parts, and then the first note is going to be worth 10 of those parts tied together. Second note is going to be worth 14 of those parts tied together, and so forth, right? So what do we use to actually notate a 60 tuplet? We need 60 equal parts, so a 60 tuplet. Well, we refer back to this. We said, what's the subdivision closest to 60, since this isn't a power of 2? So we find 64 is the closest subdivision. So what's the note value for him? What do we actually use to notate 64 beats or 64 notes per beat? So this was a quarter note, 8th, 16th, 32nd, 64th, 128th, and 256th note. So we're going to write a 256th note to start with. So right over here, we're going to say this is a quarter note. So when we have 8th, 16th, 32nd, 64th, 128th, 256th note. So we have 6 tails for this guy. So as it stands, we can fit 64 of these guys in the space of one quarter note, right? But we want to fit 60 of them. So we're going to say for every 64 of these, we're going to fit in 60 of these. So 60 in the same space as 64. That's going to be our tuplet. Now we can start actually notating this rhythm. We just made our household. So we're going to start with the first note, 10 60 tuplets, or 10 256 notes. So we introduce our power of 2 number of subdivisions as a tuplet, and we're going to say what's closest to 10. That's 8. So we're going to say we're going to fit 8 notes in the same space as 10 of these. So 8 of these, we're going to squeeze in the same space as 10 of these. Now we can reduce. We can say that 8 of these tied together can fit in the same space as 4 of these tied together, or 2 of these tied together, or just 1 of these tied together. So there you go, we reduced our space. Now we have 14 60ths for our next note. So we're going to start with our 256th note, and we're going to say, since we want the space of 14, we're going to find our closest power of 2 to 14, which is 16. So we want to squeeze in 16 notes in the same space as 14 notes. So 16 in the same space as 14. Now we reduce. 16 of these can fit in the same space as 8 of these, or 4 of these, or 2 of these, or 1 of these. There's our note. For the third one, we have 16 60ths. So 16 256 notes. We're going to start with our 256 note, and we're going to say, since we want 16 of these for that space, what's our closest power of 2 to 16? Now this is one of those exceptions where this is a power of 2. So technically we would be able to write a 16-16 tuplet, but that wouldn't be necessary. So we're just going to leave it out, and we're going to say that 16 of these guys as is can be written to fulfill that space. So now we reduce. 16 of these guys can be written to fill that space, or 8 of these guys can be written, or 4 of these guys, 2 of these guys, or 1 of these guys for that space. Now we have our next note, 5 60ths. So we're going to start with our 256th note. And we're gonna say our closest power of 2 to 5 is 4. So we're gonna squeeze in 4 notes in the same space as 5 of these guys. So 4 notes in the same space as 5. Now we reduce. 4 of these guys can fit in the same space as 2 of these guys, same space as 1 of these guys. There's our note. Last one, we have 15/60ths. So we're gonna write our first note, our 256th note. So we have this guy, we want to fit 15 of these, or we have the space of 15 of these, so our closest power of 2 is 16. So we're going to introduce a 16 over 15 tuplet. And we reduce. 16 of these can fit in the same space as 8 of these, and the same space as 4 of these, and the same space as 2 of these, and the same space as 1 of these. There's our note. So all reduced. Here's our 5-note rhythm. And yeah, that's basically it. So it can be a lot. It can be a lot, but you have to make sure you're taking it step by step, exactly how we did it. Otherwise, you're not gonna get the end result that you're looking for. So yeah, if you found it helpful, share it with a friend, drop a like, and any questions, just drop them in the comments, guys. I'd love to read them. All right, see you around, guys.